Today we're going to talk about using formulas to find area of different shapes. Yesterday we talked about finding area of rectangles and squares. Now we're going to talk about not just rectangles and squares, but parallelograms, triangles, and trapezoids. So by the end of this, you should be able to say, I can use the formulas to find the areas of rectangles, squares, parallelograms, triangles, and trapezoids. So I gave you a formula chart. Each of the shapes has different characteristics, so each one has its own formula. The key to using a formula is to figure out what each variable stands for, substitute in the numbers just like we've done all year as far as evaluating expressions, and then figure out what the answer is. Do what the variables tell you to do. So let's take a look at some examples. So this first shape is a rectangle. We're going to use the formula for the area of a rectangle, which is, as we learned yesterday, area equals length times width. And so we're going to take our length and our width and substitute it in place of the L and the W. And then we're going to do what it says, which is to multiply. So we get A equals 5 times 7, which is 35. And area is always in square units, so it's going to be square feet. It's going to take 35 1 foot by 1 foot squares to cover this shape. And that's our answer. Taking a look at the next example, we have a square here. So we have two different formulas for the area of a square. I'm going to do this example both ways so you can see both ways. We can think of this square as just a rectangle, which it is. And so our formula would be A equals L times W, area equals length times width. In this case, our length and our width are the same, so we have 3 times 3. Our area would be 9 square meters. So it would take 9 1 meter by 1 meter squares to cover this shape. Since it's a square, we could also use the formula A equals S squared. Because both sides are the same, we're going to end up multiplying side times side instead of as length times width. And so that would give us 3 squared, which we know is 9 meters squared. So you can get the answer in two different ways, depending on which formula you'd like to use. For a parallelogram, it's slightly more tricky than finding the area of a rectangle because what we have is area equals base times height. So we need to find the base and the height, which is not quite as easy as finding the length and the width of a rectangle. When you're looking for a base and a height, you're always looking for the right angle. You need to find the two pieces that make the right angle. And so here we have our height is 5 and our base is 3 because that's where the right angle is. And also just while we're on the subject, anytime you have a dotted part of the shape, that's not actually part of the shape. So this height of 5 isn't actually part of the parallelogram. So taking a look at our formula, we're going to take out the base and put in our 3. And we're going to take out the height and put in our 5. And so we get our area of our parallelogram is 15 square miles. And that would be our answer. To find the perimeter, we'd want to add up the sides. In that case, we'd want to use the 3 and the 5.4, not the 5 because it's not part of the shape. For a triangle, our formula is a little bit more tricky. We have the area of a triangle is either 1/2 base times height, which is how you're generally going to see it in any kind of algebra situation, or you can think of it as area equals base times height divided by 2, because that's the same. Taking half of something is the same as multiplying it by 1/2. So in the first case, if we're going to use our first version of our formula, we want our base and our height. And again, we're looking for that right angle. So this is what we're looking for, the 19 and the 18. So we have 1/2 times 18 times 19. So we have 1/2 of 18 is 9 times 9 is going to give us an area of 171 meters squared. If we were to do this, the second version, which is probably what you'd more likely to do if you were using a calculator, we would have 18 times 19. Then we're going to want to hit the equals or enter sign divided by 2, just to be clear that just to be sure that the calculator does what you want it to do. And so we're going to still get 171 meters squared. Either way, we're going to find the same answer. Like I said, for mental math, the first way is probably better. For calculator-wise, the second way is probably better. Our last shape is our most complicated, and we're talking about a trapezoid here. So to recognize a trapezoid, we have a quadrilateral, so it's got 4 sides, and 1 pair of parallel sides. So we have the 2 bases, are what we call them, and they are parallel to each other. Whereas unlike a parallelogram, these other sides are not parallel to each other. If we continue them, they're going to meet eventually somewhere up here. So the formula for the area of a trapezoid, because the shape is more complicated than the rest, is more complicated than the rest. So we have area equals 1/2 times the height times the first base plus the second base. And remember, we used the subscripts before when we did the slope formula, and this just means the first base and the second base, just so that we can call them both B without having to use different letters. We can number them. So we're going to take the numbers out, the letters out, and put numbers in their place. So we have 1/2 times the height, which is 10, times the first base, which, since it's on top, I'll just use the 6, and the second base would be the 20. Now we're just going to do the math, and of course every problem is a PEMDAS problem, so we're going to do the inside the parentheses first. So we have 1/2 of 10, half of 10 times 26, 20 plus 6. And then I'm going to choose to do 1/2 of 26 because we can multiply in any order that you'd like. So 1/2 of 26 is 13 times the 10 gives me nice easy mental math of 130 centimeters squared. And of course you could use a calculator, but sometimes using your calculator takes longer than actually using your brain. So when you can, try using mental math. And that's using areas to find formulas. So remember, any formula, the steps are the same. One, you should probably write the formula down first, because the more you write it, the more you'll remember it and the easier it is to use. It's also easier to use because they'll have everything in front of you that you need to substitute for. And so when you're putting your numbers in. 2, you're going to take out the letters and put in numbers in their place, and then you're going to do the math that it says to do. So in this case, it says inside the parentheses, it says to add. Then we're going to multiply, and then we're going to find our answer, and we're good. So good luck.